Have you ever wondered if time travel could be more than just a fanciful concept from science fiction? In the realm of popular culture, time travel is a captivating prospect. It's been the cornerstone of countless films, books and television shows, from Doctor Who to Back to the Future. We're all captivated by the idea of exploring the past or getting a sneak peek into the future. This fascination isn't confined to the realms of fiction, though. The scientific community has been intrigued by the concept of time travel for over a century. And the person who brought this concept into the realm of scientific possibility? None other than Albert Einstein, with his groundbreaking theory of relativity. But how does Einstein's theory of relativity make time travel a possibility, you ask? Well, it all comes down to a fascinating concept known as time dilation. Time dilation, in simple terms, is the idea that time passes at different rates for different observers. Imagine time as a river. For some it flows at a leisurely pace, while for others it rushes by swiftly. This isn't merely a philosophical concept, but a tangible reality, born from Einstein's theory of relativity. Picture two clocks, one stationary on Earth and the other on a speeding spaceship. According to relativity, the clock on the spaceship ticks slower than the one on Earth. This is not due to any mechanical fault, but rather the result of the spaceship's high speed. This effect, my friends, is time dilation. The implications of this are vast and intriguing. Could we manipulate this differential ticking of clocks to leap into the future? Well, according to the laws of physics, there's nothing to say we can't. So in essence, time dilation suggests that time travel, at least in one direction, into the future, is theoretically possible. Now, how does this notion of time dilation impact our understanding of time travel? Well, quite significantly, it turns out. It proposes a fascinating scenario where time travel, at least to the future, becomes a real possibility. Imagine hopping aboard a spaceship traveling at near light speeds. As your speed approaches that of light, time begins to slow down for you, relative to those you've left behind. In essence, you'd be traversing into the future, so the future seems accessible. However, the past, that's a different kettle of fish. While time dilation offers a tantalizing window into tomorrow, a journey to yesterday introduces a whole host of challenges. Traveling back in time presents us with a paradox. What happens if you travel back in time and prevent your grandparents from meeting? This mind-bending question introduces us to the time travel paradox, a concept that challenges our understanding of causality and reality. Picture this. If your grandparents never met, they never had your parents, and consequently, you were never born. But if you were never born, how could you have traveled back in time to prevent your grandparents from meeting in the first place? This creates a causality loop, a paradox that seems to defy logic. To resolve such paradoxes, some theories suggest the existence of multiple universes or the multiverse theory. Under this theory, when you travel back in time and change something, you're not altering your original timeline. Instead, you're creating a new separate timeline in a different universe. Time travel then, while fascinating and theoretically possible in some ways, remains a complex and elusive concept that continues to baffle and intrigue us.